Okay, so inside every single oil refinery, there's this process that's kind of like a silent guardian. It's protecting billions of dollars in equipment, but most people have never even heard of it. It's called naphtha hydrotreating. And today, we're going to pull back the curtain and see why it is absolutely critical for making the fuel we use every day.
So, to really get why this process is so important, you first have to look at the raw naphtha itself. When it comes out of the distillation tower, you'd think, hey, this looks pretty much done. But what if I told you it had a hidden flaw? A contamination so nasty it could shut down some of the most expensive parts of the entire refinery.
And yeah, this is where the trouble begins. See, the raw naphtha that comes from that first big distillation step, it's just not pure. It's actually loaded with impurities that act like, well, poisons to the next stages of refining, stages that are super sensitive and incredibly expensive. Let's meet the main troublemakers, our villains of the story. First up, you've got sulfur and nitrogen compounds. These are absolute poison to the delicate catalysts used later on. Then you have these things called olefinic compounds. They're basically really unstable molecules that love to form this sticky gum and sludge, totally wrecking the quality of the final fuel. And as if that's not enough, there are also trace metals that can literally eat away at pipes and reactors.
This really lays out the challenge, doesn't it? On one side, you've got the raw naphtha. It's unstable, corrosive, and a total catalyst killer. And on the other side is what we need, something that's stable, clean, and safe for all the expensive machinery down the line. So how in the world do you get from point A to point B?
Well, that brings us to our hero, the Naphtha Hydrotreating Unit, or NHTU for short. This is where the real magic happens. This is where that raw, flawed naphtha gets a complete makeover.
Now, the goal here is incredibly specific. You've got to get rid of all those nasty impurities we just talked about and make the naphtha stable. But, and this is the really important part, you have to do it without changing its fundamental properties, like its boiling range. Think of it like a surgical strike, not a complete overhaul. So, how does it actually work? It's a really slick four-step process. First, you take the raw naphtha and mix it with a whole bunch of hydrogen gas. Second, you crank up the heat and the pressure to get everything ready to react. Third, that mixture flows into a big reactor that's packed with special catalysts. And finally, once all the chemical reactions are done, the clean, purified liquid naphtha is separated out from all the leftover gas. Simple, right? We just mentioned catalysts, and really, they're the heart and soul of this whole operation. A catalyst is basically a chemical matchmaker. It helps speed up the reaction to get rid of the bad stuff, but it doesn't get used up itself. It just helps things along. And in the NHTU, the real workhorses are these catalysts made of cobalt molybdenum or nickel molybdenum. To make sure every last bit of those impurities get zapped, engineers actually flood the system with way more hydrogen gas than they technically need. But what about all the leftovers? Well, instead of just wasting it, they capture it and recycle it right back to the beginning of the process. It's this simple little loop that pushes the unit's efficiency way up over 90%. I mean, that's just smart, sustainable engineering right there. All right, so we've sent our raw naphtha through the hydrotreater, we've mixed it, heated it, reacted it, and separated it. So what now? Let's take a look at the really valuable, pure stuff that comes out the other side. Okay, so the clean stream now goes into a couple of separation towers. You can think of these like really precise filters that separate everything out by its boiling point. From the top of the very first tower, we get these light naphtha that become LPG. What's left over goes into a second tower called a splitter, and that's where we get two key products, light naphtha, which is great for blending into gasoline, and then the main prize, heavy naphtha. And that heavy naphtha, that is the whole reason we did all of this. It's finally clean, it's stable, and it's perfectly prepped for one of the most important and valuable processes in the entire refinery. Which brings us to the big finale. We've seen the problem, we've seen the solution, but what's the ultimate payoff? Why does this one unit, this one process, matter so much in the grand scheme of things? This quote from our source material really says it all, doesn't it? The very next step for that heavy naphtha involves some unbelievably expensive catalysts made of pure platinum. And without this hydrotreating step, those catalysts would be destroyed, almost instantly, by all that sulfur and other gunk. The result, a total catastrophic loss of production and efficiency. Here's maybe the best way to picture it. Sending that raw, untreated naphtha downstream is exactly like pouring a handful of sand into the engine of a Formula One car. It doesn't matter how powerful that engine is, how sophisticated it is, that sand will grind it to a dead stop. The NHTU, that's the high-tech filter that takes out the sand. So when you add it all up, the benefits are just huge. The naphtha hydrotreater is that silent guardian protecting millions of dollars in catalysts, making sure the whole refinery runs at peak efficiency, preventing crazy expensive shutdowns, and delivering a stable, high-quality product. It really, truly is an unsung hero. So this leaves us with just one last question. Our heavy naphtha is now pure, it's clean, it's ready for its next big step. So where is it going? What's its next adventure? Well, that's a story for another explainer.